welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 4, Lesson number 5, Percentages, Decimals, and the Calculator. So in the last couple lessons, we've kind of looked at the connection between percentages, fractions, and decimals. Today, we're going to just simply get more work on all of that, but we're going to use the calculator to do a lot of the messy stuff that we've been doing by hand, especially in the last lesson. So make sure that you have a scientific calculator, or even if not that, you've got what's known as a 4-function calculator. So a calculator that can multiply, divide, add, and subtract, right? And has some kind of decimal feature on it, and that'll be fine for what we do today. Let's get right into the connection amongst all of these very important ideas in the first exercise. Here we go. Exercise number 1. Out of 40 animals at a pet shelter, 65% of them were cats. Letter A, what fraction of the animals were cats? What is this fraction written as a decimal? All right, so in the first part of this problem, we really don't need our calculators at all, but we can talk about those a little bit in a bit. So what fraction of the animals were cats? Well, this is easy enough, right? We know that when we're given something like 65%, what that means is 65 100ths. Okay? Now, we've already talked about in the previous lesson that, of course, this is the same as 65 divided by 100, which means we could just move our decimal point 2 units to the left and get 0.65. Now, our first little bit of calculator use. If this is problematic for you at all, like changing 65 100ths into 0.65, don't hesitate to take your calculator, right? Simply type in 65 divided by 100, enter, and of course that then gives us the 0.65 that we're looking for. Now, let's take a look at letter B. Without using your calculator, what? Kirk promised I'd get to use my calculator the entire time. Okay, this is it though. Without using your calculator, use a product to find out how many of the 40 animals were cats. Check using your calculator. All right, so in the last lesson, we looked at how to find a percentage of a total. We're going to simply take that total, which is 40, and we're going to multiply by the decimal version of the percent. 65 100ths, the same as 0.65. So here we go, right? We're going to take our 40, we're going to multiply it by 0.65. Let's do that. Okay, so we've got 5 times 0, which is 0. All right, then we'll have 5 times 4, which is 20. 0, 6 times 0 is 0. And 6 times 4 is 24. Add them all up. 0, 0, 6, 2. We've got 2 decimal places, 1, 2. And looks like 26 of those 40 animals were cats. Now, in terms of checking on our calculator, that's simple enough, right? We're just going to bring our calculator up. I just want to make sure that if I do 40 times 0.65, that I'm going to get that 26. And in fact, that is exactly what we get, 26. Awesome. Now, for the remainder of the problems in this particular lesson, we may set up the product. We're going to show the product that we're going to evaluate, but then we'll use the calculator to actually come up with the product. We'll also be doing some kind of messy addition and subtraction with decimals, which we can do by hand, but we're going to use the calculator to make it faster and more accurate. All right, and let's see how that's done in more problems. All right, let me bring my calculator back down here. We'll bring it out when we need it. Let's take a look at exercise number 2. Amara goes to a restaurant where the food and drinks she orders have a total price of $54. There's a sales tax of 8% on the food. After the tax has been added, Amara would like to leave a 15% tip on the total bill. Show your work for each of the following. Letter A, how much is Amara's bill after the tax is added? All right, so the whole idea is that we need to find 8% of that $54, all right? So to do that, right, remember what we're really thinking about is 8 100ths, which is 0.08. Now again, If that's problematic for you, if you have any thinking or any thoughts that, 8% might be 0.8 and not 0.08, then set up the fraction, right? Take your calculator and just simply do 8 divided by 100, and we get that 0.08, all right? Very important. It's very easy to get 8% and 80% mixed up. But now, what we want is we just want 0.08 times our $54. All right, so let's figure out what that is. I'm going to clear this out. 0.08 times $54, and that's going to give us $4.32. Now, let me be very clear. That doesn't answer the question. The question was, how much is Amara's bill after the tax is added? This is actually the value of the tax, right? So the tax is 8% of 54, all right? So $4.32. Her total bill is going to be 54 plus this. So let's write that down first. Okay, I'm going to scroll down a little bit, right? So the total bill is going to be 54 plus 4.32. This one I think we can do in our head. It's going to be $58.32. And if you can't do that in your head, of course, you can use your calculator. So $58.32. Now, going up, right, letter B says, how much should Amara leave as a tip? Now remember, the problem says that Amara would like to leave 15% tip on the total bill. This is the total bill. So what Amara would like to do is leave 15% of this total as a tip. And that is a very standard percent that you leave as a tip. Sometimes you leave 15%, sometimes you leave 20%. Kind of depends on the restaurant, the location, the country, things like that. So how much should Amara leave in a tip? Well, again, 15/100ths is the same as 0.15. So I'm going to take 0.15 and I'm going to multiply by 58.32. So maybe let me write this. The tip equals, and let's figure out what that is. All right, let me clear this out. 0.15 times 58.32 equals 8.748. Now let's talk about that just for a moment, because that can't be our final answer. She can't actually leave $8.748. She can't do that because there are no fractions of a penny unless apparently you go to a gas station. But what we should do is we should round this to something that's reasonable. So it should be rounded to the nearest penny. That would be 8.7 something. That 8 tells us we should round the 4 up to a 5. So how much should Amara leave in tip? 8.75, which will be slightly more than 15%, but that's okay. Better to leave a little more than too little. Anyway, the last part of this question says, what is Amara's total cost, including the tax and tip? Well, we know that after tax, she's got to pay $58.32. Then she's going to add in another 8.75 in the tip, so we simply need to add the 58.32 to the 8.75. So literally, 58.32 plus our 8.75. This one I don't feel like doing in my head. All right, so let's add those up. 58.32, there we go, plus 8.7, come on, 7, there we go, 5, enter. And her total bill is $67.07. All right, so good example, right, of where we're taking percents, converting them to their decimal equivalents, then using a product of that decimal equivalent with a total to come up with some part. In this case, this was a tax, right? In this case, this was a tip, and then adding those onto the total to get some kind of total cost. All right, a good example of an applied problem that actually comes up pretty much anytime you go out to a restaurant where there are tips. And certainly pretty much anytime you go out to a restaurant, at the bare minimum, there's going to be tax. All right, let's keep working with this idea and using our calculator to calculate percents. So one of the places that we see a lot of percent work is you'll see something called percent increase and percent decrease. All right, let's take a look at that in exercise number 3. Tristan and Naomi are both getting pay raises this year. Tristan currently makes $720 per week and is getting a 12% increase. Naomi is currently making $985 per week and is getting an 8% increase. Who is getting the larger raise in terms of actual dollars, and by how much? All right, so Tristan is getting a 12% increase, but that's only 12% of 720. Naomi is getting a smaller percent increase, 8%, but of a larger amount. So what we need to do is find 12% of 720 and 8% of $985. So let's lay it out there. All right, very important that we actually lay out the calculation. So first, let's do the 12% of $720. All right, I'm going to go immediately to the product stage. 12% is 0.12, right? We want to multiply that by 720 to figure out Tristan's raise. Again, we're going to do that on the calculator to make it a lot faster. 0.12 times 720, enter. And it looks like Tristan is going to get a raise of $86.40. I know it says just 0.4, but we all know that 0.4 is the same as 0.40. All right, so there's Tristan's raise, right? He's going to get 86.40 because he's getting a 12% raise of 720. All right, now let's find out about Naomi. For Naomi, we're going to get an 8% of 985. So let's figure out what that is, all right? And again, going right to the product stage, 8% is 0.08 times 985. Let's figure out how much we get there. 0.08 times 985 gives me $78.80. So it's now easy enough to look at these two values, $86.40, $78.80, and know that Tristan's getting the larger actual raise. But they also ask by how much, right? And by how much is just going to be subtraction, right? So what we want to do, is we don't want that. What we want is we want 86.40 minus 78.80. And again, we'll do that on our calculator. Here we go. So 86.40 minus 78.80, enter. And that's going to be 760. So Tristan is really the answer on this. Tristan's raise, and that's going to be by that $7.60. So he gets a slightly bigger raise. Now, it's interesting because he's getting a bigger raise because his percent, 12%, is much larger than Naomi's 8%. But they're not very different because 12% of 720, right? 720 is a much smaller total to begin with than the 985. We're going to be looking at different phenomenon about that with sort of like, finding percentages of different totals. We'll kind of get to that as we move on. But again, a good example of taking a percent, changing it into a decimal, multiplying it by a total to get sort of a part, if you will. So let's keep moving on with these. Let's take a look now with percent decrease. So notice with percent increase, we had something that we were starting with. And then we said, oh, this number goes up by, let's say in the last problem, by 12%. So we find 12% of the original number, and then we add it on. Percent decrease is very similar, except we're going to find a percent of an original number, and then we're going to lower that number by that amount. Let's take a look at that in exercise number 4. The temperature of a cup of coffee decreased by 26% in the first 5 minutes after it was made. The coffee starts at 190 degrees Fahrenheit. What temperature is it after 5 minutes? All right, I'd like you to pause the video and see if you can figure this one out. All right, so the first thing that we have to do is understand that when they say that the coffee decreased by 26%, not the coffee, but the temperature of the coffee. My coffee would have decreased by 100% within the first 5 minutes of having it. But, if the temperature of the coffee is decreasing by 26%, what that means is that I need to find 26% of 190, right? That's what I have to start at the beginning. So here we go. 26% of 190 degrees Fahrenheit. Well, that's going to be easy enough. I'm going to take my percent and change it into a decimal. That'll be 0.26. And I need to multiply by 190. That is a beautiful looking 0 there. All right, so this is simple enough. Let me do 0.26 times 190. And that's going to be 49.4 degrees Fahrenheit. Now, let me just emphasize, right? That is not the temperature of the coffee after 5 minutes. That's actually how much the temperature went down, right? So this is how much the temperature decreased. And let me kind of abbreviate it a little bit. That is simply how much the temperature went down. Now, if I actually want the temperature of the coffee after 5 minutes, I'm going to have to take my 190 and subtract off my 49.4. That's going to be easy enough, right? 190 minus 49.4. Again, we're going to just do this using our calculator. Here we go. 190 minus 49.4, and that's going to give us 140.6 degrees Fahrenheit. So there's our temperature after 5 minutes. So percent decrease works very similar to percent increase. The big difference is, right, we take whatever we're starting with, we multiply it by the percent that it's going to go down to figure out how much it went down, and then we're going to subtract that amount from what we began to figure out what we ended with. All right, let's do one more problem. Now, there are some weird things that can happen with percent, and I want to take a look at one of those in this final problem. Exercise number 5. The price of gasoline 1 week was $3.40 per gallon. It increased by 15% the next week. The week after that, it decreased from 15% from where it was the second week. Letter A asks us to find the price per gallon of gasoline after it increased by 15%. All right. So this is simple enough. What I'd like you to do is pause the video now and figure out what the price of the gasoline is after that $3.40 increased by 15%. Pause the video now and figure out what price the gasoline is. All right, well, let's first find 15% of $3.40. Simple enough. I'm going to just bring this up a little bit. So I'm going to do 0.15 times $3.40. Come on, 40, there we go. Bring my calculator out. Let's do 0.15 times 3.40. And that's 0.51. Again, I gotta really emphasize, that is not the price of the gasoline, right? That is how much the price went up, right? So the price went up 15% of the base price of $3.40. So the new price is going to be $3.40 plus 0.51 I'm going to do that one in my head because it's pretty easy. And that gives me $3.91. All right. Now, letter B. Find the price of gasoline after it decreased by 15% from its price in A. All right, so now what I want to do is I want to take my price in A, $3.91, and I want to lower it by 15%. Now this is going to get a little bit ugly again, but I'd like you to pause the video and see what price the gasoline is per gallon after this price goes down by 15%. Pause the video now and take a few minutes to do that. All right, so now what we want to do is find 15% of 391. So let's do that. 0.15 times 391. And we'll do that on the calculator. So 0.15 times 3.91. Uh-oh, that's not right. Let's try that again. 0.15, my calculator's a little laggy today, times 3.91. I slow down for it a bit. There we go. That took a little bit. 0.5865. Now, again, we have to realize, though, that we're going to round that. So that's going to be 0.59. All right? 0.59. All right, when I round that number to the nearest cent. Now, again, that's not the price of the gasoline, right? That's how much it went down. So let's figure out the price of the gasoline now by taking our 391 and subtracting off our 0.59. All right, let's do that over here. So we get our 391 minus 0.59, enter, and we get $3.32 per gallon. Let me move this out of the way. Now, this is really rather strange because, right, the price of our gasoline went up 15% and then it went down 15%. So, common sense would say, well, then we should be back to the price we started at. I mean, if we started at $3.40 and we went up 50 cents and then we went down 50 cents, we'd be right back at the same price. But here, we went up 15% to get to $3.91, then we went down 15% and we got $3.32. We started at $3.40. So that's what letter C is all about. Letter C says, the price in B should not be the original $3.40. Why did the price not return to this original price, even though the percent increase and decrease were the same? So what I'd like you to do is I'd like you to think about this, write something down, and as a hint, let me just mention that it wasn't due to the rounding that we did here, right? We had to round that to 0.59. If we had rounded it to 0.58 and subtracted it, it wouldn't have made any difference in terms of sort of like getting back to the original price. So that's not it. Why didn't it return to the original price? Pause the video now and see if you can write something down. All right, well, it's pretty much this simple. We were finding 15% of two different numbers, right? In letter A, we were finding 15% of $3.40. In letter B, we were finding 15% of $3.91. So plain and simple, right? We found 15% of two different numbers. And that's why it didn't drop by the same amount, right? 15% of 340 is different than 15% of 391. One of them was 0.51, the other one was 0.59, right? So simply the amount we added on and the amount we subtracted off, although they were the same percent, they weren't actually the same amount. Okay, let's wrap all of this up. Okay, we didn't see much that was new today, right? In other words, we continued to calculate the percent of a total by multiplying by a decimal. The big difference today is we were able to do a lot more of them. And the reason why is because we had the calculator, right? And that is a huge, huge deal. Being able to basically say, hey, look, if I want to find 5% of a total, I'm going to just multiply by 0.05 of that total. And I can now do that with a calculator, which is going to be faster and more accurate. All right, so we're going to keep using the calculator in order to solve a lot of percent problems as we move on in this unit. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.